Send too much data in the JVT token is again a problem which doesn't represent a security vulnerability, but we again don't only discuss security vulnerabilities here, we discuss faults, mistakes that you should avoid when developing an OAuth2 system. What you should mind is that the token itself, when you use a JVT token, indeed it has the nice feature and you have the nice opportunity to transfer data from the authorization server to the client and then back to the resource server using the token itself. So you can put actually data in the body of the token because it's called JSON Web Token for a reason. It's just a JSON. It's in the end a base64 encoding of a JSON representation of data. But mind that there are two reasons why you should be very careful with what you add to the token. First of all, if you send too much data on the token, then the algorithm used, the cryptographic algorithm used to sign the token, the larger the token is, the longer it takes to the algorithm, and so the more resources you need to spare to sign the token itself. If you have a short token with not too much information, it takes less time and less resources to sign it from the cryptographic algorithm point of view. If you have a large token, then it takes more time for the cryptographic algorithm and more resources to sign the token as well. And then the same thing on validating the token. So when you validate the token, if it's shorter, it's easier for the resource server. If it's longer, then it's not that easy anymore for the resource server. A second thing to think about is that you still use the network to send your requests and responses. So it's still, even though networks today are higher and the quality of sending the data is higher than we had maybe 15 years ago or 20 years ago, that doesn't mean you now have to transfer a lot of data and you can put full I don't know, megabytes of information directly on your JVT token. So you always need to make sure that you find the best way to send the data so that you don't overflow your network. And now that I've said that, I also remembered that I've seen again a vulnerability regarding to exposing sensitive data, where developers actually at some point used the token to send sensitive information inside the token, like the user's password. So that's not something you have to do. Sensitive information, if you use a JVT that's only signed and not encrypted, then mind that it's only then HTTPS that maybe protects that data from being visible and accessed. But trust me, in the real world out there are ways through which HTTPS can be turned over. So you don't want to only rely on HTTPS. It's of course definitely mandatory to use HTTPS. So HTTP is for a long time not a good choice you would like to use when exposing any kind of web application, but it's not enough. So when you send information like card credentials, like credit card credentials, credit card details, and so on and so forth, you don't send them unencrypted on the wire. So that's very important. Don't use your JVT token to store sensitive information. The JVT itself also can be encrypted, so it's called the JVE, and that's from JSON Web Token Encrypted. And in that case, basically, that's something you might want to use to send information that you want to not be directly exposed on the wire. But mind that using an encrypted token is not necessarily a better solution than using only a signed one. And the reason we mainly use signed tokens and not encrypted tokens is because when you encrypt the token, it takes a longer time. So you really don't want to encrypt all your tokens. You encrypt only tokens that you really know it's mandatory to encrypt. If you don't send sensitive data on the wire, then it doesn't make sense to encrypt that data. You can simply use your JVT token only signed, the way as we do in most of the applications. Number 5, send sensitive. I said that before. I didn't remember that I've added this point here, so I already explained it. Number 6. So number 5, send sensitive data in the JVT token. It was actually what I was trying to tell you that you shouldn't do. So you have indeed the possibility to send sensitive data in the token, but then you need to encrypt it and not sign it. Yeah, I really forgot I had this point here. I totally I thought I actually considered it with number 6. I forgot that I actually added a separate point for that as well. But again, it's a good point, so that's why I separated here probably when I wrote the presentation, is because it's an important thing. Be aware of adding sensitive data in the JVT token itself. Let's go to number 4, because I guess you understood that already, why is that important. So registering the same client credentials in multiple applications. What I saw often with systems nowadays is that there are multiple applications that a specific user can use for the same feature. Like, for example, you have a web app and a mobile app that's running on Android, iOS device. You already have 3 applications if you have that. Sometimes I even see more web applications relying on the same, more different web clients relying on the same resource server. What's the problem with that? Is that it seems that developers tend to believe that if they represent merely the same thing because they use the same endpoints, then they can be considered the same client and they use the same client credentials on the applications. And that's not okay, because the client credentials, they are called credentials because they are still sensitive details. So you want again to make sure that you use them in as few places as possible. So if you have 3 applications, don't configure the same client credentials on all the 3 applications. Each application will have a different set of credentials, even though that might make it a little bit more difficult for configuring it at the authorization server. No, this is not the order of importance. That's what I was saying at the beginning, that I only put them just one after the other, the way they came into my mind. So it's not ordered by importance. I wouldn't say that they are even ordered by the way you find them in real world examples. The order of importance is debatable, so I didn't want to order them in any way, because they are all of them important. So yeah, it's basically I don't want to say that one is more important than the other. So no, this is not the order of importance, and not the order of how often they are found in real world examples. It's only the order they came into my mind. Now, don't ask me why I've numbered them descending. I don't know that. That's probably my mind upside down sometimes. So I could have simply numbered them from 1 to 11, and I have numbered them from 11 to 1, but that's because of my mind upside down, not because it means anything. So all of them are of the same importance, or at least take them from this presentation as being of the same importance. Yeah, registering the same client credentials in multiple apps, I've seen that a few times. It's not a good choice in terms of, first of all, if someone manages to steal the credentials for one app, then it already has the credentials for all the others. And besides that, you don't have then the opportunity to log properly the events at the authorization server side where the tokens are issued, because usually you want at the authorization server side, you want to be able to also make some auditing at some point, just log who issued some token, what client, maybe for what user, if the request failed or not. And you maybe store that in a Splunk database or in an Elasticsearch to be able to do some auditing later in case you have any problem. And if you use the same client credentials, then you simply won't be able to know if your request came from the Android app, or it came from the iOS app, or it came from one of the web applications. So simply, and at least only for auditing, it's better to just make sure you have different client credentials. Number 3, using the client credentials grant type to implement functionality that accesses user resources. This is a very big one. this is quite important in terms of severity. Not necessarily that I've seen this often, but I've seen this a couple of times at least. And that's applications having a user. So managing user data using not a user grant type, but the client credentials grant type, which doesn't require any kind of authentication. So I've seen that in a very complex and unnatural way, that application, if I remember correctly, because it was some years ago, but it was basically somehow doing a login, and then if the login was successful, it was storing a state, and then it simply used OAuth2, but it used the client credentials grant type for accessing data, accessing endpoints that retrieved or changed the data that belonged to the user. So that's really it's a really strange way of doing that. But I actually saw the client credentials grant type used for accessing the user's data, and that's not okay. So when you configure your authorization rules, you have to make sure that endpoints or any way of accessing the functionality that works with users' data and is only accessible via a grant type that requires the user to do a consent. Make sure that the user agrees the client changes or retrieves their data. Otherwise, this is a vulnerability. The client credentials grant type is useful, but it's useful when you don't call a functionality that manages users' data. One of the most common examples I give is when you have a monitoring application, and that monitoring application has to call, say, in case of a Spring application, you might use the Spring actuator, and you use the Spring actuator to expose details that you then want to see on your monitoring app. Of course, the heap dump, the beans from the context, the thread dump, whatever the monitoring app takes, they are not users' data. They are simply data related to the app. So then you don't need a user consent for that. And that's where you use the client credentials. You can secure and you must secure those actuator endpoints. But if you secure them in an OAuth2 approach, then the grant type you would use is the client credentials, because that's not user data, so you don't need a user grant type to access them. And basically this way, the client becomes the monitoring tool. The monitoring tool will use the client credentials to call the endpoints it needs. So client credentials grant type is useful, you need it, but just make sure you don't use it to call endpoints that expose or use the user's data. Not securing the Spring actuators endpoints on both the authorization server and the resource server. That I was discussing in my example about the actuator. In my earlier example in point 3 about the actuator. One of the very important things to take into consideration is that when you use the Spring actuator, which is, for those of you who might not know, the Spring actuator is a dependency used with your Spring Boot applications that comes out of the box with exposing details about your application. Usually you need them for monitoring and debugging purposes. But what happens is that you need to secure these endpoints as well as you do with your business endpoints of your application. So you have to make sure they are secured. And there are plenty of ways you do that. The most often encountered way is making sure that the actuator endpoints can only be called on a different port that is not exposed in the ingress and egress of your infrastructure. That's usually very relevant, and a lot of infrastructure considers that nowadays. But still, even inside your infrastructure, you still have to secure them. And then whatever you can use is basically you can use Spring Security to make sure that you need a set of credentials, for example, to call the Spring actuators endpoints. And if you have an OAuth2 system, then you must make sure somehow that you use either the client credentials grant type for your resource server, for example, to allow the calls to your actuator endpoints only in a secured way, or at least another fashion in which you authenticate the requests, but you don't leave your actuator endpoints to be for free, so freely accessible. I see people sometimes don't take that much into consideration the Spring actuator endpoints. They say, well, my business endpoints, they use the user's data, they are the only important, the Spring actuator is not important. But actually the Spring actuator sometimes exposes very sensitive data. Remember, through the Spring actuator, you can even expose the heap dump of your application or the beans you have in your app's context. And these are very sensitive details that can expose the structure of your application, and of course, even if you have access to a heap dump, even sensitive information that some individual might not should not have access to from outside. So they are still very relevant, and you still need to secure them. And it's a vulnerability to leave your Spring actuator endpoints unsecured. Number one, which is again not number one in terms of importance, it's just number one, like in my case, the last one, because I'm upside down, using long living access tokens. So don't make your access tokens live too long, because someone steals a token, then that someone might be able to use the token if it doesn't expire, unless you revoke the token. And the longer the lifetime of an access token is, the more probable is that someone can actually use that. So it's shutdown is also, and now I saw your message. Shutdown is also one of the most sensitive. In my experience, people don't usually expose that one. You know that anyway, by default, the Spring actuator only exposes the health and the info endpoint, which theoretically are not that sensitive. But if you then expose more of them, then they might be sensitive. And yes, if you expose shutdown, then you might get into a very difficult situation in which your application simply stops. But it's probably one of the, we can call, most sensitive endpoints of the actuator. Yeah, now the long living access tokens, again, what I was saying is that probabilistically speaking, the longer you leave an access token, the more probable it might be used for accessing a resource. So it's usually just consider them as client sessions, and it really depends which is the greatest the greatest time you need to choose for the life of a token. But you usually need to make them short-lived, so that if stolen, is less chance for someone to use them.